Hello and welcome to my project. We titled it Graphs and Stats. My name is Weston Grant and I'm a finance major. And my partner for this project is Colin Minshew, who's an early education major. This project is for Math 134. So in our project, we explored the numbers of four types of cancers in the United States, this being brain cancer, lung cancer, breast cancer, and kidney cancer. The purpose of our research is to understand how many people are affected by those cancers in different parts of the country. To do this, we're using information from trusted sources like different national databases and scientific studies. Our goal is to make sense of all of this data and see if there are any patterns or differences between states. By doing this, we hope to learn more about cancer and how it affects people across the country, which could help doctors and researchers find better ways to prevent and treat these diseases. We used various different articles to give us a base knowledge of the cancer types that we chose. One example of these is an article titled The Most Common Cancer in the U.S., written by Dr. Lynn Eldridge. This article gave us a base knowledge of cancer and shows us things like cases versus death. It was very beneficial to us at the start of the project when we didn't really have any knowledge on the topic at all. This right here is our original data set, and on the left side of it, it shows the state name. The next row shows the cancer deaths for all the types of cancers in each state. And then every row after that shows an individual type of cancer. And from left to right, it goes brain cancer, and then breast cancer, prostate cancer, colon cancer, kidney cancer, and then on the far right is lung and bronchus cancer. So these were our basic statistics that we calculated. This was the first thing that we had to do in Excel. Uh, the first thing that we calculated from the mean, was the mean, which is the average uh, number of deaths for each type of cancer in all the states. Next, we had the median, which is the center of the data for each type, and then we had the mode, which is the number that came up the most. Some of these didn't have a mode because none of the numbers repeated. And then we had the standard deviation, which is a measure of how far data is from the mean. And then we had the variance, which is a spread between the number of the numbers in our data set. And then we had maximum value, which shows the state, like the number that, like the state with the most amount of cases. And then the minimum, which is the least amount of deaths for each cancer type. And then we had our percentiles, which we start at the 25th percentile, and then we move on to the 75th percentile. Moving on, we have our histograms. A histogram is a graphical representation of the distribution of numerical data. A histogram consists of a series of bars. Each of those bars has a range of values, and then the height, like how high it is, represents like how frequent it is in that range. So for our x-axis, we have each of the 50 states listed, and then the y-axis on our histogram represents like how many deaths that state had, and then each graph is its own type of cancer. Like on the left side of the top, we have the breast cancer, and then kidney cancer, and then lung cancer, and then the far right graph is brain cancer. So this was kind of our depiction of each one of these graphs. This is our distribution for them. We studied each of them and had to conclude which way the data was distributed. We found that each of our selected cancer data types was pretty normally distributed. Normally distributed data in a histogram is like that needs to be symmetric from the mean, and that's what we found with ours. When we looked at our data, most of the peaks were symmetric. There wasn't an overload of peaks on one side or another. This led us to believe that each of them was pretty normally distributed. So moving on, we have our box and whisker plots, as you can see on the left. The top two are brain cancer and breast cancer, and then the bottom two are kidney and renal pelvis, and then lung and bronchus cancers. So a box and whisker plot is a concise and informative way to display the distribution of a data set. It summarizes key statistical measures such as the median, quartiles, and range. The box in the plot represents the interquartile range, also known as the IQR, which has the middle 50% in the data, while the whiskers extend to a minimum and maximum values within a certain range and are often determined by a chosen criteria such as 1.5 times the IQR. Then the outliers beyond these whiskers are typically marked individually. While these may look similar at a first glance, you can see that some of these have a lot higher outliers than the other. So, like for example, the brain cancer has a mean of 345, while its biggest outlier is 2,540, and then breast cancer has an even larger outlier of 2,960 or 29,360. So when we compared the box and whisker plots, we found similarities and differences. We studied them and broke them down to see things that we noticed. And then on the bottom of this slide, it shows the first quartile, the second quartile, and the third quartile for each for each variotype that we chose. So for the similarities, we found that brain cancer, kidney cancer, and lung cancer, all of their first quartiles numbers were pretty close. And then breast and lung cancer second quartile numbers were both in the 3,000, so they were pretty similar. And then for the differences, we found that breast and lung cancers have higher numbers all around the chart compared to kidney and brain. And then another difference is that the third quartile numbers between brain and breast cancer are significantly different. So these are our pie charts. The first on the left being kidney, and then we move to lung, and then breast, and then brain. The brain pie chart is on the far right. These pie charts are another way of showing how the data is distributed, similar to a histogram. The pie chart gives an easy to understand format of how the data is represented. So like if you look at it, so we chose 5 states and showed which had the higher rates, and the bigger the allotment that state has on the pie chart means more cases and deaths in that state. The 5 states that we chose were Alabama, Florida, Georgia, North Carolina, and South Carolina. As you can see, most of them have Florida having the most deaths. And then these are slides for the part 2 of the project. This slide shows our scatter plots. Scatter plot is a type of data visualization that displays the relationships between 2 variables by plotting individual data points. On the different scatter plots, we put the least squares recognition equation as well as a trend line. In the chart below, we broke down the equation into the slope, which is n, and then the intercept is b, and describe them and what they mean for each equation. So the top 2 scatter plots are for, on the left, kidney and lung cancer, on the right, brain and lung. And the bottom have breast cancer and brain cancer, and then the bottom right is kidney versus breast. This is our correlation matrix for the 4 types that we chose. A correlation matrix displays the pairwise correlations between variables in a dataset, revealing the strength and direction of the relationships. So 1 indicates a perfectly positive correlation and 0 is no correlation. It helps identify patterns, independencies between variables, aiding in the understanding of the structure of the data. So our 5 important findings of the project, number 1 being lung and breast cancer have some of the highest number of death rates for cancer in America today. Brain cancer is a cancer that only affects women and that has one of the highest death rates among the different types of cancers. The number of cancer cases in California is highest among all states for each of the 4 cancer cases we chose to study. The number of cases for District of Columbia are super low for each cancer case, but that's understandable. And 5 being the number of cancer cases largely vary based on the size of the population of that specific state. Overall, we felt that this was a great project to both learn about cancer death rates in the US while also learning the basics of how to use Excel.